Hello, everybody. Thank you for joining us. I am Audra Montenegro with O'Reilly Media, and will be your host for today's webcast. Today we have Ben Simonds, and he is going to talk to you about 3D modeling, creating cycles, node materials, and blenders. Ben Simonds is a professional 3D artist and a co-director of Gecko Animation Limited, a post-production and computer animation company based in London. Simonds' popular Blender tutorials appear on his website, bensimonds.com, Blender Cookie, CG Cookie, and Blender Nation. All right, folks, as we get our webcast started, I would like to go over some housekeeping tips to help you get the most out of today's event. First, you'll want to open the group chat widget if you haven't already done so. This is where we will interact with each other during the event and where you'll submit your questions for Ben. We find that our audience usually has a lot of good knowledge to share, so we do encourage you to chat freely during the event. However, if you have questions for Ben, please be sure to preface them with a capital letter Q so we know that it is for him and we can make sure he sees it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget, you'll need to give it permission to access your account. Our hashtag today is 3D modeling, all one word, and the Twitter widget will automatically append that to your tweet so you don't have to. If you have any problems during the event, we encourage you to look at the help widget, which is very thorough. If you continue to have problems, post in the chat room and one of our staff will help you. For choppy audio or stalled visuals, try refreshing your window, and remember that the best thing you can do for a good audio stream is closing any apps that could be interfering. So because people always ask, we would like you to know that we are recording today's webcast and will have an archive available, usually within 48 hours. And that link will be sent to you via email. All right, folks, and at this time, it is my pleasure to turn the program over to Ben for his presentation. Hello, Ben.
Hello. Thank you very much for that introduction. All right. Hi, everyone. So I thought I'd talk today about creating node materials in cycles. So as Audra said, I use Blender in my day-to-day. I have a small sort of animation studio along with my business partners on Relax here in London. And we do stuff for commercials, short films, print, all sorts of stuff. And like I say, Blender is pretty much our workforce for that. And we're both big fans of the new Cycles render engine. So I thought I'd talk today about just some tips and tricks for working with node materials in Cycles. So that's me, that's who I am. So node materials got added back when the Cycles render engine did, which I think is a couple of years ago now. So it's still relatively new to Blender. And they're a really powerful, reusable way of creating materials. They can do all sorts of things, work with different ways in data. And they're very powerful ways to create materials. They're also really reusable, modular. You can take chunks of a node setup, reuse them elsewhere, and they're very powerful. But they could also be complex to manage. Once you have a lot of nodes going on in your material, it can get sort of tangled up and look pretty complex to the outside observer. And even for yourself, it can get a bit crazy. So I thought I'd talk about some tips and tricks for managing node setups, making them look tidy, making them user-friendly, and some ways of using groups that also not only make things sort of more accessible, but let you do things that you couldn't do without node groups. So I'm going to talk about that today. So let's talk about the basics of what a node material is. So if you add a material to an object in Cycles, you'll get something like this, which is just one shader node and one material output node, and a connection between the two. And obviously, this doesn't take too much to figure out. It creates a fairly basic material with a basic diffuse shader, and all of the settings that you would need are already available to you. But as you go on creating more complex materials, something like this maybe, which is just a simple combination of a diffuse and a glossy shader, this is still pretty readable, but you obviously need to keep your sort of socket types matched up, and things like that. But you can see now you've already got a couple more settings that you need to keep track of, and things are getting more complex. So what happens when you've created a bit more of a complex material? So I thought I'd talk about managing node setups. Well, the first obvious thing you can do is just try tidying up your scene, renaming some nodes. That's something you can do, coloring them, things like that. So I'll open up the screen share now and hopefully show you my window and talk about that a bit. So hopefully everyone should be seeing my screen pretty soon. So this is a little demo file that I've got here. And I'm actually going to open up a different one just to show you a bit about node materials. So this is the spider robot from my book, Blender Masterclass. And he's got a relatively complex material. You can see it in the node editor here. And I've got a few different texture inputs on the left here, a couple of different shaders that are here, and some nodes connecting those in between. And it's all still pretty accessible. I wouldn't expect to sort of figure out everything that was going on at a glance, but at the same time, it's not a massive tangle of nodes, but you can still do a couple of things to tidy this up. So I've got my shaders over here, and I don't really need access to every socket that's available here. So I can hit Control H and hide those sockets that aren't being used by these shaders, and then I'm not interested in changing the values of. This is a very simple way of just tidying up node setups, and I do it quite often just to make things look more presentable and easy to read when you're trying to figure out how a node setup works. The other thing I do is put things in frames. Frames are a useful tool when you don't want to group stuff together, but you do want to make it clear that a group of nodes, not a group of nodes, but a collection of nodes, is all part of the same thing. So I've got my 3 image textures here that I'm using for the diffuse, specular, and roughness of my shaders. So I'm going to combine those into a frame just by selecting them all, so shift right-clicking them, then selecting the frame and hitting Control P. And that adds them all to the frame, which is already a useful way of just making everything look a bit tidier and making it obvious that these are all part of just a group that's useful to be aware of. Now, if you hit N and bring up the Properties panel of the node editor, you can also set things like the label on that frame. So I can change this to textures, if I can type it correctly. And you can see that that's now named textures. And I can also set a custom color for this frame. So maybe just by picking this color box here and then setting a custom color below. So I'm going to make that red. So that's a nice way to just start going about tidying up your node materials. But the really powerful tool is nodes. Not nodes, sorry, groups. So groups work by selecting a whole bunch of, or as many nodes as you like, and hitting Control G. And that groups them together into one system. Now, it immediately takes you into the inside of that group. But if I tab back out, you can see that these have all been combined into one node. And if I tab back in, just like going into edit mode in 3D view, I get access to what's under the hood of that group. So here inside, I've got my diffuse shader, and I've got my glossy shader. So if I try to make the sort of user interface for this material more useful, I could rename these inputs for the group. You can see these on the left are the inputs for the group. I can add new ones. If, for example, I had another shader that I wanted to control, so if I just add in a diffuse shader that I'm not going to use here, I can drag from this any socket here, any input socket for that, to create a new input socket for the group. I can also delete that if I no longer want it, just by selecting it on the right here in the Properties panel again, and hitting X to delete that. So let's delete that shader I don't need. Now, a really useful way of using groups is just to make, like I said, the user interface of your material better. This is great for if you have a team of artists, you have one guy working on shading, but maybe another providing textures, or just maybe different people working on different aspects of shading and lighting. You can make it obvious what different parts of your node setups do. So I'm going to reorder and rename these inputs on the left into something more useful. So I've got 2 color inputs here, and I'm going to differentiate them just first by sort of reordering them so that roughness is at the bottom, so they all line up nicely. That's just a bit of OCD on my part, but it also makes the system more readable. I'm going to name that first color input diffuse, because that's where I plug in the diffuse color of my material. And I'm going to rename the second one glossy color. I should probably make it clear that these are both colors, so I'll name that one diffuse color as well. And the third one has already been called roughness because it's been automatically named based on the input of that glossy BSDS node. So if I tab back out, now I have 3 inputs to my node group, which I could also rename to something more useful, maybe diffuse and specular, or glossy I should say. And you can see on the outside of this group, I have 3 really useful, well-named inputs to the group that tell another artist who's looking at it a bit more about what that node group does and make it really easy to change the inputs to that and know what the effect will be. So that's one use of groups. But that's really just a bit of housekeeping, making things look tidy and nice. So I thought I'd talk about some other methods and more powerful things you can do with groups. So that's how node groups work. A bit of a slide on that. So one thing you can do is you can then reuse this combination of nodes that you've just created. So you can take a node group for a common material type, for example, combining a diffuse and a glossy shader is something you'll do again and again when you're creating materials for your project. So if I had 10 materials each that had a combination of a bit of diffuse and a bit of glossy, all in different ways, I could reuse this diffuse and glossy shader that I just created in that screen share. If you just, in the node editor, hit Shift-A, you get access to any groups you've already created, and you can add in another instance of that for another material. So that's one way of using groups to your advantage with nodes. But you can go further than that. You can also create some simplified controls for your node groups, like I just demonstrated. I've got another demo of that here, in fact. So I'll share my screen again. And if I open up a different blend file here, I've created a sort of car paint material. And this is just a combination, again, of a bit of a glossy material and a diffuse material. But I've blended them together with a layer weight node within this setup. And I've got a mix node going on here affecting how much the diffuse color affects the specular color. But this isn't particularly user-friendly to work with as a node group. So I've assigned some inputs and grouped these all together. And on the outside of the group, you can see I've just got one input for layer weight, one for the sort of roughness of the glossy shader, and one for the amount by which the specular color is affected by the diffuse color. And on the outside of this node group, I can just play with these in a really sort of user-friendly way, change how much the material is how white the glossy reflections are, change things like the layer weight, so I can have more or less specular, things like that, which is a sort of user-friendly way for an artist to use the material rather than having to go in and figure out which node affects which things. So yeah, that's another trick for using nodes. Another tip is that you can use node groups to control multiple materials, but from the same node setup. So I have here in this example a whole sort of bunch of different materials. I've got 3 different materials here, a red, yellow, and green for sort of weird traffic light things. And but I can manage these all from one node group. So I'm going to go back to the screen share again and demonstrate how that works. So if if I switch to my traffic light scene, you can see that cycles render preview there. It's giving me a real-time look at what my material does. And on the right here, you can see that this object has 3 different materials assigned to it. And if I were working maybe in Blender internal or in just cycles without node groups, then to change the color of that red material, I'd have to select the red material, go into its properties, change the color to red. Then if I wanted to change the yellow one, I have to select the yellow, find the node in that. But what I've done is something slightly different. I've placed all the material sort of nodes into one node group, and I've just connected it up on the outside with different outputs. So for the red material, I have a red output of my node group. For the yellow material, I have a yellow output of the node group, and for the green, a green. So that's pretty straightforward. But if I tab into this traffic light, you can see that I've got essentially 3 different shaders that lets me access all of those different materials at once. So I've got 3 different emission shaders, one on red, yellow, and green, and then I can tweak these all at once without having to switch back between different materials. So I can, make them purple and yellow and orange and whatever. So that's quite a fast way of getting control over multiple materials by using a node group. And the other efficiency about it is that I can make things consistent across all of those 3 materials. For example, as well as having an emission shader here, the balls are also slightly glossy. You can see a bit of a reflection on them. And that is provided by just one glossy shader node that's then added to each of those 3 emission shaders. That means that when I change the roughness on this glossy shader, if I turn that up to 0.5, all 3 materials are affected at once. So I don't have to go in and change 3 separate material properties. I just tab into my node group and change all 3 at once. So that's another useful way to use nodes and groups. So I thought I'd put these principles into practice and talk a bit about some specific examples of using node groups and using some other tips and tricks for nodes by talking about creating materials for glass. So glass is a really complex material. There's a whole bunch of different ways that rays interact with glass. Rays will reflect off like a mirror reflection if you look at a low angle at a pane of glass. They'll also obviously refract through it, like they would through a lens or glass, whatever. But glass does also cast shadows. So we'll have shadow rays in our scene that are cast by a glass object. And then the converse of that is that the refracted light that goes through the glass will also create hotspots, be focused into areas, and so will create caustics. Caustics are sort of secondary illumination from light that's been either refracted or reflected by a glossy surface or by a transparent surface. Not transparent in the shader sense. I mean something like glass or water. Now, of course, Blender does have a very simple way of setting up a glass material, and that's the glass shader node. And obviously, that's a very quick way to set things up. It also gives you fairly photorealistic glass. The downside of it, of course, is that it relies on ray-traced caustics for the shadow of the glass and for the light being focused through it. This is really slow to render, and if you want nice caustics like you'd see on the bottom of a swimming pool or in the sort of refracted light through a wine glass and its shadow, you're going to have to wait a long time and use a lot of samples. Now, sometimes this is fine. If you're doing a still, you can just turn the samples way up and go away and make yourself a couple of 100 cups of tea and drink those and come back and have a lovely render. But if you're rendering an animation or you want something a bit quicker, then you're going to have to find another solution for rendering glass. Now, in different situations, there are different ways you can approach this, and there are different ways of getting quick results for glass. So I thought I'd talk about simplest first, which is glass for architecture. Now, thin glass, like you get in a window pane, has no noticeable refraction, really, because both surfaces of the pane of glass are parallel. So we don't really have to worry about refraction too much. And also, no caustics are required, because although light is going through the glass, it's just going straight through. So there'll be no sort of focusing of the caustics, and we can basically just treat the material like it doesn't cast a shadow at all. To do this, we just combine a transparent BSDF shader with either with a glossy shader. Basically, I'll talk about that now. I'm going to share my screen again and jump into my architectural glass scene. So you can see a Cycles render preview sort of coming together of this. And this material is only composed of a transparent BSDF shader, glossy BSDF shader, and an add shader that just adds the two together. Now you can see there's light coming through from the outside from a sun lamp I've got in my scene here. And on the inside, there's a little bit of illumination as well, just to lighten up the room a bit. Now these glass windows are basically just sort of cubes that have been flattened down and placed in those window frames. And if I move them away, you can see in the Cycles render preview that the brightness of the room barely changes at all. Now that's because basically this transparent shader is not casting any shadows, and the glossy shader is then only adding to the lack of shadows of the shader. The glossy shader basically just provides a little bit of reflection on the window. The way a transparent shader works, by the way, is if you set its color to white, it casts no shadow. If you set it to black, it becomes completely opaque and so casts a shadow. Sorry about that. If I then jump back to my slides, that's a very simple shader for doing architectural glass. But we do want perhaps a more complex glass shader in certain situations. So this combines a bit of the architectural glass shader that we've just seen by using the transparent shader, but it does refract light. So we've got a bit of a lens here in this example. This is very efficient to render. It doesn't use caustics. You can have caustics turned off in the render settings of your scene, but that object also isn't casting too heavy a shadow. And to do this, we've used the light paths node. So once again, jump back to screen share. I'll take you through that. So if I jump into my glass scene, and that's a bit of a preview of the next material that's coming up. But this is just a very simple glass shader. You can see in the preview here that it's not casting too heavy a shadow, but there is light reflecting through it. And that's just as a result of a combination of a glass BSDF shader that handles the refraction. But when we're treating the material as something that's casting shadows, we're using a transparent BSDF shader. And to do that, we've used the light paths node. This is a really, really useful node. And what it does is it gives Cycles info about what kind of ray is being traced for that material when it comes to render time. So you can see it's got a bunch of inputs here called is camera ray, is shadow ray, is diffuse ray, and so on and so forth. And that tells you what kind of ray is being evaluated for that shader at the time. So if it's camera ray, we're talking about a ray between the camera and the object. So if you're looking directly at its surface. For the shadow ray, we're talking about rays between the light source and some other area of the image, and we're talking about whether that object is casting shadow on something else. So for here, we've taken the is shadow ray output of that light paths node and plugged it into the mix shader. That means that when we're looking directly at the object with any other kind of ray, it gets treated with this glass BSDF shader. We see nice refractions, things like that. But when the object is casting shadows, it gets treated as a transparent BSDF shader. And that means that we can affect our shadows here and make them darker or lighter. And that gives us a lot of control over the amount of shadowing that that glass object causes. So that's a bit of a simplified glass shader that would render very quickly, doesn't require caustics. But there's a bit of something lacking with it in that we'd like maybe to sort of try and fake caustics a bit, or just try and affect the look of a bit of a hot spot in the shadow of that object. So I was kind of casting around for a a way to do this, and I came across a great blog post by Bassam Kadali of the sort of Tube Project and Blender Open Movies fame. He came up with a really elegant solution for doing some quite simple fake caustics with cycles. So I thought I'd take you through that and explain how this shader works. So you can see in the render preview, I hope you're all getting a good view of that I've got a nice sort of hotspot in this shadow now from the lens. And that's as a result of a sort of useful extra feature of this transparent BSTF shader that I've talked about. Now you can see here there's some inputs and stuff going on being plugged into the color of that transparent shader. If I disconnect them for a minute, so I'll just sort of flash through that noodle connection, you can see that this lens is actually casting kind of an anti-shadow at the moment. And what's going on there is I've set the value of that color to be greater than 1. And that means that essentially, instead of casting a shadow, it brightens up rays that have gone through the lens and makes it brighter in where the shadow would naturally be. Now, the clever thing about this shader that Bassam came up with was using a bit of sort of geometry and vector magic to sort of blend between that anti-shadow and the real shadow. So what he did was he took two sort of geometry inputs called the normal and incoming vectors. The normal is just the sort of vector pointing away from the surface of the object when you look at it at any angle. So that's a sort of constant for the object. The incoming vector is the angle of the light coming towards the object. And the dot product of those vectors that we've taken with this vector math node basically just gives you an idea of the angle between those objects as a sort of ramp between 0 and 1. So it'll give you a value of 0 if those two vectors are kind of perpendicular and facing in completely sort of orthogonal directions. It'll give you a value of 1 if they're both pointing along the exact same direction. I hope I said that the right way around. Then what we've done is just put that through a bit of a color ramp to sort of muddle those up, and multiplied that by 3 just to get that sort of anti-shadow effect by setting the value of the transparent BSTF shader to more than 1. And if I connect that back up, then we get the nice sort of fake caustics result. And if I jump to my render settings, you can see that no caustics is turned on, so there's no real caustics turned on, but we've got a sort of nice fake caustic material going on here. If I just show you just the transparency at the moment, by just jumping to a preview of that node, I'll explain how that works later on. It's an add-on and I'm using. You can see that also that would work for the sort of viewing of the object if I don't have this business with the light path node going on and mixing in the glass shader. So that's a few different solutions for doing glass in cycles. I thought that would be useful because quite often you're sort of working on a scene and trying to work out the best way to do glass, and you just whack in a glass shader and it doesn't look A1. And if you think about the sort of different ways that you're tracing light for different aspects of the shader, it can kind of help make something more A, quicker to render, and B, a bit more sort of user-friendly to figure out what's going with your object. So let's jump back to the slides. That's the explanation of what the different light paths are. I just nabbed that from the Blender wiki. I'll let you sort of go through that later. I think you guys can download the slides, or you can just look it up on the Blender wiki, as I say. So that's a bit about glass. I thought I'd use the remainder of my talk to talk about something that is very dear to my heart. It's a really great sort of quick and dirty trick for doing materials in cycles, and that's using vertex paint. Vertex paint's brilliant because you can really quickly just create some kind of input for your material that doesn't require you to UV unwrap your object. You can do it for something with a million polys that you really would hate to have to unwrap and get looking all cut seams and things and unwrap it properly, or if it's got terrible topology, it still works. So vertex colors are great for that. And you can also bake now directly to vertex colors. You have to do it in Blender internal, of course, but you can bake things like ambient occlusion or textures or things like that into vertex colors. And also within the vertex painting tools, you have something called dirty vertex colors, which basically let you automatically paint a cavity map for your mesh. So you can see in this example at the on the bottom right here that I've got a little head that I've sculpted, and I've sort of decimated that. And you can see the material on there is a sort of grungy patinaed metal. And in the crevices, it looks kind of dark, but on the exposed bits, it's kind of nice and shiny, which is sort of reasonably realistic for something. But you can see from the shaders setup, the nodes there, that it's actually pretty simple. So I'll take you back to the screen share and just go through how I made that. So if I go to my scene for him. So this guy here was just a little sculpt I did, and I've decimated him down and made him into one object for the purposes of this tutorial webcast. And to vertex paint him, I literally just hit V, went into vertex paint mode, and if I paint this back, I'll do set vertex colors. That just sets the vertex colors for the whole object to whatever you've got selected here. I just went paint, dirty vertex colors, wait a few seconds, and there we go. We've got sort of dark areas in the crevices. We've got light bits on the exposed parts. That's a really quick way to just get a bit of sort of texture to your object that depends on its geometry, which is quite often very useful when making procedural materials. To get access to that in the cycles node material, I'll just jump back to object mode. All you need is an attribute node. Now, the attribute node has a couple of uses. It lets you get access to different UV channels if you've got more than one set of UV coordinates. It lets you get access to vertex colors. I think it does one or two other things. I can't think of them off of the top of my head. But to get access to something, you basically just type in the name of that thing that you want. So here, I've typed in the name of my vertex color channel, which is just coal, which is the default. And if I look at that as my cycles material, you can see it appearing in the render preview there. I then just put that through a color ramp to sort of sharpen up the differences between the sort of crevices and the exposed areas. Made that a bit sort of whiter overall, but darker in the cracks. And then I've plugged that into the factor input for a mix shader. And all that's doing is mixing together a sort of dark green diffuse shader with a nice sort of brassy, coppery, glossy shader. And that mixes those two together and creates sort of nice, very quick material that looks kind of grungy and old. But, you know, I did no texturing there. I didn't hand paint anything. I didn't have to UV unwrap anything. And yeah, I've got a fairly sort of robust looking material. So that's a favorite trick of mine. And I thought I'd demonstrate a couple of other uses for that as well. So another way to use vertex paint is as a way to sort of blend between different kinds of materials. And in this example, I've used it to create a candle. Now, this was something I actually messed about with before subsurface scattering got introduced into cycles. And I wanted to make a sort of glowing candle, but there was no subsurface scattering yet. And although the translucent shader kind of does a bit of that, it doesn't do a very good job. So I decided just to fake it. And to do that, I used vertex paint. So I've got this sort of candle that I sculpted here, and I've got two sets of vertex colors on it. One, if I hit V and go into vertex paint, is the glowy areas of the candle. So I've just hand painted this with the vertex painting tools. I can paint sort of areas I want to be brighter and darker just with the vertex paint tools here. I won't do too much of that because it's a little slow with the webcast, I think. And the other was, again, a bit of dirty vertex colors and a bit of ambient occlusion that I just baked into the object. And then I've plugged that into my material just by using, again, an attribute node to get access to the object, the vertex paint, put that through a color ramp. And for these sort of dirty vertex colors, I just plugged that into a mix node for colors and into the diffuse node. So that's just a slightly grungy looking diffuse shader there. For the glowy parts, I took the second vertex paint channel, and then put that through a color ramp to give it sort of glowy, fiery colors, so from sort of yellow to orange to red to black. And then plug that into an emission shader. And then I also use that same set of vertex colors to just create the blend between emission and the diffuse shader, and used a mix shader to combine those two together. So that was a sort of glowing candle effect that I created. And there's no subsurface scattering there. It's very, very quick to render. You can see it's rendering very fast on my machine that's suffering with doing the webcast as well. And yeah, that was a sort of quick and dirty trick for using vertex colors for something a bit unusual, I think. So I've got one more tip for vertex colors because they're pretty much my favorite thing, which was this is the material we created earlier that I showed you, that sort of car paint material. And here I've punched some sort of rusty looking holes in it. And that's done with vertex paint yet again. So if I hit V and go into the vertex colors for this object, I've just painted some very rough black splodges on the surface of the object. And then these I've roughened up by doing some procedural materials as well. You can see if you look close at the render preview, hopefully that shows up. Oh, that is a bad way to display it, but hopefully you can see it. That, you know, it's got nice jagged edges here, and if you remember the vertex colors, they were all very smooth and very low res, and I'll explain how I did that. So what I did was I took my vertex colors, again, plugged it into the material with an attribute node, and put it through a color ramp, beginning to see a pattern here. And then I took a couple of procedural textures. So I've got one noise texture and a Musgrave texture. And I've mixed those two together a bit, put them through a color ramp, and then overlaid that with the vertex color input. And that creates a nice sort of crackly edge to that vertex painted hole that I punched in the mesh. Then I just can combine materials using those as a mask. So I've taken a transparent shader. You can see the whole thing disappears. And my car paint shader. Oh, it's interesting that preview's not working. But anyway, that's the car paint shader. And I've just combined those with a couple of mixed shaders and a couple of other basic shaders just to create a bit of an underlay to that paint. And mix those together. So if I mix the transparent with the basic diffuse material, I get the sort of undercoat of that paint, but with the holes punched in it from the transparent shader. And that's using that color ramp. And then I use another mix shader to mix in that car paint, just with a slightly softer color ramp, so I can still see those edges. And then I've got a material that's got holes punched in it. It's about 50% procedural, 50% painted by hand. I've not had to go in and do any sort of detailed edges to those holes. If I wanted to make another hole, I could do so very quickly. I could probably jump into vertex paint now and just add another one in here. Let's see if I can do this. Oh, my computer's slowing down too much. So if I jump back out of vertex paint, I've now got another hole punched in my mesh. It was very quick to add. I haven't had to destroy any geometry. It's completely non-destructive. I can paint that back out again. But it's quite a convincing material, I think. I think it's kind of useful. So that's a fun way to use vertex paint. So let's jump back out of that. So that was a few tricks for working with vertex paint and using them in cycles, no materials, which is, yeah, like I say, it's a favorite trick of mine and I use it quite often. So that's what I wanted to talk about today. Thank you all very much for listening, and I think I'll take some questions now if people would like to sort of put them to me.
Fantastic. Excellent presentation. We do have a few questions here from the audience. Jeff wants to know, on a scale of 1 to 100, where do you rate the bulk of the content and exercises?
The bulk of the content and exercises of what? I'm not sure I understand the question.
I'm not sure. That's where the question ends. Maybe Jeff will elaborate once he hears this. We can move on to the next question in the meantime. Ian wants to know, is there a particular setup you use for absorption properties of glass?
Absorption properties of glass. Yeah, that's it's something that's quite tricky to do. If you're talking about sort of glass coloring light as it passes through, obviously, maybe I'll share my screen again here. So if I create a new material on this object, I'll just create a glass shader. Basic one. Then on a basic level, I just change the color of the glass, right? And now it's red. But that's kind of only how it would look if that glass was sort of pure red. Certain other objects have a sort of more volumetric look to the coloring that you'd receive through passing through it. Like if you had some murky water or some stuff with ink in it or something like that, then if it passed through a really thin bit, you might not get much coloring at all. But if, I haven't put it on screen share, sorry about that. There we go, you should be seeing it now. Apologies. So I've added a kind of a red glass shader here, and I can make it any color. Like I said, on a more realistic material, you'd expect thicker bits to be colored more and thinner bits to be colored less, right? And that's kind of a slightly tricky thing to do in cycles still, because we don't really have volumetric support, which is kind of what you'd need for that. But there are ways you can go about doing it. I've seen various setups that people have posted, and it's kind of a hacky result of using this light pass node again. What you have as one of the last inputs here is a thing called ray length, and you can use that to determine how far a ray has passed through an object, and then use that to affect the color of the glass material. Now, I probably shouldn't try and do it now because it takes a lot of fiddling and isn't really easy to do. Basically, you take that and stick it into the color input, but then you'd have to put it through a math node because those ray lengths are given in Blender units. So you have to sort of try and figure out how to compress that to a value between 0 and 1. So I guess you want to sort of multiply that by, I don't know, you can see if I multiply by different values, I'll just get different sort of amounts. And then sort of stick that through a color ramp. Am I going to get lucky? Is this going to work? Okay, you can kind of see it there. No, I'm not sure if that's really working. I think I've got that the wrong way around anyway. Okay, well, I made an attempt at it. Basically, that's something like what you do. And if you really fiddle around with the values there and tweak it a lot, you can kind of get something that looks like it's filtering light. So I hope that answers that question a bit. I didn't do a terribly good job, but that's the principle of it anyway.
It looks like it answers the question. And then also, Louis wants to know, do you have a tip to improve or reduce the noise when we are using materials like glass or glossy?
Yeah, I think I can give a couple of tips there. The first thing to do is basically I almost always turn off caustics. So you tick this, it's a bit backwards because to turn off caustics, you turn on the no caustics option, which is bizarre. I don't get why it's that way around. But yeah, you turn that option on. That's going to reduce the amount of caustics you get. Obviously, it's going to also mean that you have to set up your material in a way that means that it'll still be shaded correctly and still look like it's not casting crazy shadows like I talked about earlier. But that will reduce a lot of noise. The other thing I do is generally turn on clamp. I set that to something pretty high, usually 10 to 100 in that range. It depends on sort of your lighting setup. Obviously, you don't want to restrict it too much if you want to have some bright light in there and some good highlights. But that's another way to take down the noise a little bit. Particularly for glossy and specular materials, turning on filter glossy a bit also helps. This just basically sort of blurs out glossy and specular secondary rays, I think. So things that are causing caustics and makes them a bit softer and results in slightly less noise. It's not always helpful, but sometimes it is. So that's a couple of tricks. If you want to go more in depth into that, you can do things like switching from simple path tracing to branch path tracing. This lets you sort of determine relative amounts of samples for different things. So you can see in this sort of samples window here, I can now say I want to do 4 glossy samples for every diffuse sample that I do. And so you can kind of skew the amount of samples you do for different ray types in favor of the ones that are causing the most noise. So that can be kind of useful to play with if you're having trouble with a particular kind of ray, which is often true of glossy samples, or quite often true of subsurface scattering as well. It's really can be often quite handy for that, because that's another one that causes a lot of noise. If you don't want to render 1 million samples for every type of ray, but just a lot for subsurface scattering, you can turn that sort of subsurface scattering amount up without affecting the amount of rays you're casting for other things too much. So that's hopefully a couple of tips for that.
All right, excellent. And Dom wants to know, what is the absolute minimum hardware requirement to get the best out of your book?
For the book, I'm trying to think what the most complex scene in that is. It's probably the sculpting on the back creature in the book. I think I took that to something like 4 million polys, something like that. And the main constraint on a system for that is obviously RAM. And I think you probably want, on the safe side, to have sort of 8 gigs of RAM for managing that. You could probably get away with 4, I don't know. As far as the other aspects of your system are concerned, the CPU is going to obviously be the main factor in how fast you render, along with RAM. But sort of other hardware requirements aren't too important. Your GPU isn't terribly important for using Blender. Obviously, it affects how fast you can navigate around the UI and the 3D viewport. But when it comes to rendering, unless you're doing GPU rendering, if you've got a really fancy GPU card, unless you're doing that, then it doesn't actually affect your render times at all, because you're rendering 100% on the CPU and using the RAM for memory. So, yeah, I guess maybe a decent amount of RAM is probably the most important thing. And apart from that, a decent sort of modern CPU. But you can get away with a fairly sort of standard, I'm sure your regular kind of laptop or PC that you might buy these days would probably just about do the job.
Fantastic. Ronald also wants to know, when making group nodes, do you have to leave the material output outside of the group?
I think you do. I think if I try and group that up, oh no, I can do it. Hey, there we go. You don't have to, no. But off the top of my head, I don't know how that works for everything. Because, if I then added that to another material, would it automatically sort of find that and realize that it's got an output for the group? I don't know. I haven't tried that before. That's a good question, probably worth experimenting with. I would avoid doing it unless you have a reason definitely to do it, and just stick with a sort of shader output of your group, and then plug that into the material output outside of the group. I think that's probably a safer way to go about it.
Okay,
but maybe there's some clever thing you can do.
It looks like he was asking it in regards to the group output.
Yeah. Basically, the material output node has no outputs of its own, no output sockets. So you're not going to have a group output if you sort of stick that inside a group. But yeah, I haven't played too much with doing that, and I can't think off the top of my head of a good use case for doing that. But maybe there is one.
All right. And Owen has a specific question here. How would you change the areas that allow light to pass through, like dirty glass or foam on water?
Oh, okay, that's a good question. So you could use the transparent shader again. So like we did for that sort of fake caustic setup, there we used some vectors and some a bit of sort of vector magic to get different areas to have different transparencies. You could do the same thing just with the texture though. So I could just make this into a transparent shader, this object here. Let's set it back to that simple material I had earlier. Or maybe a different one would be better for this. Switch back to the caustic scene. So instead of those fake caustics setups that I had, I could just stick in, well, let's go back to my classic example and use vertex colors. So if I hit V, I could then, if this was a sort of dirty lens, I could paint around the edge this sort of area here and a bit of that, and then stick that as my vertex color into the transparent shader as the color. And then you can see that now those areas that I painted black are casting shadows, and those areas that I left white are not casting shadows. So if you had a dirty pane of glass, you could kind of use that and use the color of that transparent shader to affect how much shadow it casts. So obviously for the clean areas, leave it white. For the dirty areas that would be casting a shadow, paint it a bit darker. And you could use, a texture that you'd hand painted, whatever, vertex colors, procedurals, any method to generate that input for the transparent color. So that's kind of how you do that.
All right. And Frank wants to know, what do you think about branched path tracing to reduce noise?
So I talked about that with the reducing noise for sort of glossy samples and subsurface scattering. I find it really useful in certain situations, like if I know my scene has a certain type of shader that's causing most of the trouble, and it's a subsurface scattering shader, or it's a glass shader that has a lot of refraction going on, then it can be worthwhile to use branch path tracing for that, because I know the culprit, I know the type of sampling that I need more of. On the other hand, if I've got a scene that just has a lot of complex lighting, or that has an HDR map with a lot of stuff going on it, then I tend to stick to normal path tracing, because frankly throwing more samples at it is sort of, because the problem is kind of general and more samples are just needed overall, why mess about with specific types of ray? If you're going to have to throw more samples at it, just throw more samples at it. So that's kind of the two approaches that I would take. If you don't know what's causing the problem, stick to just adding some extra samples. If you can work out what's causing the problem, and if it's kind of one specific kind of ray, then switch to branch path tracing, and you can fix that problem by directing those extra samples at the specific kind of shader that you want to make less noisy.
Excellent. JT wants to know, do you have any other good quote-unquote fakes to speed up rendering you can share?
Fake setups. What do I usually do? Off the top of my head, I can't think of any good ones. I used to sort of mess around with fake subsurface scattering shaders in cycles, because obviously that was something that got added relatively recently. And I would try and use the translucent shader and mess about with that. I don't think, though, that was really faster than doing proper subsurface scattering, because, in fact, I think the translucent shader is probably one of the more noisy ones. So that was kind of more a workaround for creating fake subsurface scattering that's now been sort of replaced. Off the top of my head, I can't think of any other good ones. Sorry about that.
No worries. We'll move on to the next question. Here, Jerry wants to know, how do you generate the dirty AO vertex colors map on the head model?
Okay. So it's just something you can do from straight within Vertex Paint. So if I switch back to him, you can see him there. And I'll just start from scratch. I'll delete that set of vertex colors that I've got. So if I add a new set of vertex colors, I'll hit on that plus there. You can see at the moment that there's nothing going on in the material as far as the vertex colors are concerned. And if I hit V and jump into vertex paint mode, you can see that this whole mesh is just white. To do dirty vertex colors, to do this sort of cavity paint thing, it's just under the paint menu here. Click paint, click dirty vertex colors. It's all procedural, so you just wait a few seconds while it sort of bakes all those cavities, and there you go, Bob's your uncle, done. You can also add to that ambient occlusion. So for that, that's what I did for the skull, and that's why it has a bit more sort of depth to it in those sort of sockets of the eye. I'll do it for this guy as well, in fact. To do ambient occlusion, you're going to have to bake textures, which requires you to use the old Blender internal. It still has life in its veins. So if I sort of get this guy on his own and turn on bake, if I bake to vertex color, turn that option on and do ambient occlusion, this will replace the vertex colors that I've already got. So I'll lose that dirty vertex color. But there's a reason I'm doing this first. Turn on normalize and hit bake. That'll take a few seconds. If I jump in now, you can see that this is sort of more geared towards the sort of areas that light wouldn't hit. One other thing you can see is that it looks kind of jaggy when you zoom in, and that's because the way it splits the faces up to render the ambient occlusion, it forgets which vertices are connected multiple faces. So to fix that sort of jagginess, you can just do paint smooth vertex colors, and that sort of smooths it out a little bit. If you want to fix it further, then you kind of want to turn on blend and just go at it sort of by hand. You can then multiply that with dirty vertex colors. So if you do dirty vertex colors, no matter what you've got on your model already, it kind of multiplies with it. So if I apply that again now, then I have some of the deeper shadows from the ambient occlusion coming through with the sort of more fine details that you get from the cavity map. So I find that a useful trick sometimes. And if I jump back out of that and go to cycles again, turn on my render preview, you can see this has gotten a bit darker now, so I might want to play with the color ramp here. Let's just look at that. That's more like what I want. So yeah, that's how you do dirty vertex colors and baking into colors into vertex maps, vertex colors.
All right. We have a couple more questions here. Louis wants to know, what do you see in 3D software's future, respectively, to Blender?
Well, with Blender, I feel like I'm being sort of asked a question for Ton or someone. Blender's a fantastic tool. I love it. And I can only see it getting more and more used by studios, people with sort of serious interests in CGI, in visual effects, things like that. A lot of the development in recent years has been geared towards visual effects, certainly with the Durian open movie, Tears of Steel. I think that's been a terrific direction of development for Blender, and it's one that myself and Jonathan here at Gecko have used quite extensively and benefited from. I think that's a really great direction it's gone in, and I hope that continues. I think, I think that's my answer. I don't think I have anything more salient to say on that.
All right. Last question here. Frank wants to know, do you plan to make any kind of workshop or course in video format in regards to your book?
That's a good question. I've had a couple of inquiries about that, about doing courses, some about doing sort of real-life courses in London here. I haven't had people ask for video courses before. I do a bit for Blender Cookie every now and then, and a couple of other sites, and I publish small tutorials from time to time on my own website, bensimonds.com. I would love to do a bit more of bigger tutorials, but my main work is usually doing stuff here at Gecko and working on our projects there. So it doesn't leave me much time for doing kind of more in-depth tutorials. But hopefully I find time for a bit of that from time to time.
All right. Well, we thank you so much for this fantastic presentation. The audience really enjoyed it, and we can't wait to have you back in the future. Is there anything else you would like to leave them with before we end the webcast today?
No, thank you very much, everyone, for joining in and listening, and thank you for all your questions.
All right. So thank you, audience, for being with us. And again, thank you, Ben. This was so great. And we do have an offer for your book. It's our deal of the day. So you can use code DEAL to get it for 50% off or 40% off the print book. And we push that link out to you in the chat log. So, yeah, everyone, have a fantastic morning, afternoon, or evening to wherever you all are from. Goodbye.
Bye.